All right, so another reaction of aldehydes and ketones, and it's not just a reaction of aldehyde and ketone. You'll be making an aldehyde and a ketone here, or not and. Okay, so this starting material we had before also. Okay, so if you want to look at that reaction, that would be synthesis 3, in which I actually made an aldehyde. So this one is going to be slightly different from that, because an aldehyde is a terminal group, and here are alkene, I guess you can say is terminal, but it's not really terminal. So let's look at, it could be called terminal, yeah. Anyhow, let's look at how we're going to make this. So first of all, to check on what we have is we have 2 carbons here, and we have 1, 2, 3, 4 carbons here, and you can go either way, right? 4 or 4 there. I think the top 4 is better because that includes the double bond. So which means you're adding 2 carbons somewhere along the line, okay, here. So to add 2 carbons, and it means you need to form a carbon-carbon bond. So a carbon-carbon bond can again be formed by either Grignard reaction, or you can also add an alkanide. Either of those two will work. So if you look back at synthesis number 3, I have done both of these syntheses. Okay, so I encourage you to look into that, because here I'm going to do a little bit different, okay, kind of synthesis. So that way you have multiple things here to look at, okay, because this is slightly different from what we did before. So it's not exactly the same, but we are still adding a couple carbons, right? So we still need to do a carbon-carbon bond formation. So let's go ahead and get started. And I am going to do the Grignard first, okay? Because, when I see my double bond here, I can see my ketone here, okay, or an aldehyde. I'm seeing a ketone because, there is carbon-carbon on both sides. So this is a ketone, not an aldehyde, which is why I kept saying that the alkene is not terminal, even though it is terminal, because I was visualizing ketone already. I was working my way backward. So in any case, so I'm seeing the ketone over here. So if I have a ketone, that means, that's what I need over here. So again, there are a couple ways of doing this, and I'm going to do both of them here for you, so you can see, that there's more than one way of thinking. Okay, but the first thing I want to do here, or the first synthesis that I want to do, is go ahead and make Grignard. By the way, you can see that the benzene ring is not doing anything, because it's just the benzene ring, so I'm not going to draw it. I'm just going to write pH for that. And then here, I'm going to go ahead and add magnesium. So now we're going to have 2 carbons and then MgBr, okay, over here. So in this case, since I'm making a ketone, I have to add when I make my alcohol has to be a secondary alcohol. So if I have to make a secondary alcohol, I have to treat my Grignard with an aldehyde. Okay. Now remember, formaldehydes will give you a primary alcohol. Any other aldehyde is going to give you a secondary alcohol. So what I need is 2 carbons more, right? So this is what I need. 1, 2, 1, 2, 3, 4. And then the last thing that I need on here, to remove this, and I need to draw my carbons again. So 1, 2, 3, 4. And then on the third carbon is where I'm going to need my ketone. Okay, so if that's what I need, it means I'm going to start with an aldehyde like this, CH3CO, and then H, right? So that will give me the 2 carbons, and it will give me a ketone. Okay, so 1 and then 2 would be the H3O plus. It's a good idea to write the H3O plus. Otherwise, you'll end up getting like an O minus, which will never get protonated. Not a good idea, okay, to do that. So now once I have my ketone, I need to just go ahead and replace that oxygen with a carbon, and the only way to do that is by Wittig. Okay, and so the last reaction is going to be a Wittig reaction, and in that Wittig reaction I need only 1 carbon, right? That's the only carbon that's there. So PH3 P and then CH2. Just write this as a lone pair of electrons. Okay, so it's technically sort of a carbene, but it's a carbon anion. Okay, because it is negatively charged, and that's the nucleophile. Okay, that you have. So this is what you're going to do for the first synthesis. Now I'm going to draw a second one also for you. Okay, the second one also is pretty easy to do. So let's start with that. The second synthesis, I'm going to add an alkyne. Okay, so we still have the same starting material, which is the 2 carbons. And then now in this case, I'm going to add an alkanide ion. And alkanides are made from taking ethyne in this case and adding sodium amide to that. So now I'm adding 2 carbons. So now I will go ahead and get my 4 carbons on there. So 1, 2, 3, and then the fourth 1, 2, and then I have the triple bond, right? That's what I have. So now from the triple bond also I can get a ketone, because now all I have to do is add mercury sulfate, okay, to this one. So HgSO4 in presence of sulfuric acid, that will give me ketone. Okay, so now pH, and then I still have the 4, 1, 2, 3, 4, and that. Okay, so I have 2 different ways of making a ketone. The last step is still the same, okay, which is the Wittig. So now in this case, same thing, pH 3, and then triphenyl, and then here is the methine. Sorry, not methyl, methine. Methylene, and then you get your product, okay, at the end. So the difference between the two is not really a whole lot, okay, so it's just 1 step or 2 step difference. And so actually it's even like just, no, they're both 3 steps. So it depends, which one do you use? You can use whatever you want depending on whatever reagents you have in the lab, because both of them are pretty viable synthesis. Okay, you don't get any side products, you're not losing anything, everything is just okay. All right, that's it.